next presentation comes from Kemal Delic from the Open University in the UK.
Thank you. So you see on first slide, AI-Augmented discovery. Discovery is a kind of long jump forward. Currently it's about inquiries in which AI may help discoveries. Known knowns are probably labeled as a science. Unknown knowns, it's research. And unknown unknowns are discoveries. I will use a series of vignettes just to give you an idea or a seed without trying to go into any details. Reason being I'm obliged to apologize for audience, which is mainly engineers, developers, and people having hands-on, while here it will be more about architecture. And I will be hinting that AI will transform high-performance computing into cognitive computing. And if you look at the Science February magazine, there is an article from Jack Dungara and others on which we have posted that science was developing like quantitative phase, then mathematical phase, then computational phase, and for the future it will be cognitive age of science. So AI infused into infrastructure with huge amounts of data. So only quickly about me, I spent 24 years with Hewlett-Packard as a technologist and architect. I was with Energo-Invest with 12 years, with Consiglio Nazionale di Ricerca for 2 years. I'm senior editor with ACM Ubiquity magazine. I'm European Commission advisor and evaluator, and also I hold patents. Owner is HP, but I'm inventor of those patents. It doesn't go? I'm sorry. All slides here are vignettes from something which was published. So you may take a look at the extended text, since vignettes are pretty visual in a sense of a lot of elements. Now, yeah. Thank you. Which one? It works.
It was the right button. It
Yep.
just wasn't plugged in.
Oh, I see. Okay, here is something which is probably known to all of you, that in big picture of the world, we have society putting money on science, science developing technology, technology stimulating economy, and then in a closed circle, society benefiting from this. It's unfortunate that big crises, wars, and pandemics are advancing science. So when you think about radar, about computers and other, so it's nearly always that unfortunate events are bringing other things, including nuclear. You know, it was used for military purposes, but then there is a kind of use for production of energy. Then on the right side, you see something which is kind of usual cycle of observation, creation of theories, experimentation, and simulation. And it goes endlessly around. And typically, it's that for theories, people have been looking at the libraries, books, and eventually getting inspiration and using quite often instinct to create theories which sometimes stay for 100 years not being experimentally proven. Then observation and experimentations are typically in data warehouses as a big container of things. And simulations have their own repositories. Going around, and this is an endless cycle of observations, creation of theories, and experiments and simulation, bringing new angle of this. Now, here is something which no need to convince you that problems are always kind of marked by rising complexity. And when you look at the diagram on the left side, you see that storage goes from giga to exabytes, and flops, computing cycles, go to exabytes. Exaflops, which on the top will be exploration of the universe, most likely will require exa scale. While by now we see already petascale desktops, which can be used for proof of concepts, for demos and other things. Decomposing problem into something being constraints, being on speed, scale, of accuracy, you will come to the point that you need somehow to look at the problems in different way. If you imagine that on the right side of the screen, you see 3-age architecture, which is hyperscale, hybrid, and heterogeneous. Upper part is about computation, which is CPU, GPU ensemble. Then NPU is in reality neuromorphic computing boxes, which or chips, which might be also analog, not only digital, might be combined. And then in a longer distance, QPV is about quantum, and it's something which creates heterogeneous architecture, which today probably is mainly upper part computation, while what I'm saying is that cognition might be addition to see cognitive systems in the future. Here is an end-to-end view of something which is called most recently distributed computing continuum. In reality, we are facing oceans of data, and it's known that if you look at the velocity, then $9 billion gadget, which is accelerator CERN, is about velocity of data. Volume will be astronomy, SKA, which is global infrastructure for astronomic purposes. Variety is about medicine, about genomics, and probably that this is a place to mention DeepMind, which probably is the most recent breakthrough in this domain, as you know, about protein research. And web media, with the billions of users, Meta has 3 billion users. Imagining that each time it's individual, then you see that veracity of this will be of high importance, meaning that aspect of privacy and security will be highlighted here. This is something which I have published on European Commission blog some 10 years ago, 2016, projecting, I will not say in details, only just a big vignette, in which at that time scientific world was around 25 supercomputing data centers, and it was by that time it was obvious that winners will be those American companies providing commercial cloud services. Below is a data grid, which is in reality scientific grid which preceded academic clouds. And at that time, it was not yet clear what would happen, how to combine world of scientific data with commercial data. Therefore, in the middle, you see meta broker, which is probably a kind of catchword to point at something which may require inventive or innovative things. And at the end, it will be probably difficult to find a solution how to combine commercial and scientific world because of legal reasons and because of constraints on scientific data. You know that the usual test of time is like in academic conferences, if after 10 years you have still something published and being cited, then you might be declared as a test of time publication, which is important. This one is published in 2008, and it was about emergence of academic clouds. And it was on ACM ubiquity. And looking into this, you may see that we have early guessed or predicted, whatever you take as a good word, that we will have as a 10 clouds. Today probably the figure is 3, 5 to 7. We talked about tens of thousand data centers. Today's are like tens of thousand data centers. Billions of devices and gadgets, but on the edge, trillions of sensors and other things. So structurally, we have been talking about emerging computational megastructure and data centers morphing into data grids, and power of clouds becoming so important that we might see new kind of science appearing. So that was prediction 17 years ago. Now, something which is a recent poster from one US conference in which it is a sketch of the idea about AI-Augmented cancer advisor. When you look at this fingerprint, idea is to show, to combine personal DNA with environment in which you're living, with lifestyle, eating habits, and trying to create a fingerprint for a person with approval, and then looking at the public domains, which is on left side, and then looking at the private domains or protected, which is a kind of medical administration, as a clinical notes, electronic records, or clinical trials, then that you somehow establish a fingerprint which you can use for analysis, for eventual diagnosis, prognosis. All this is something which looks as an augmented cancer advisor, helping oncologists to do better and trying to combine knowledge from public domain, from private knowledge, and to advance. Just to stress that provisional patent filing in US is done on this. Another example is climate modeling, and as the majority of people here is extremely familiar, I will quickly just say that the composition of the model, which is on left side, is 6 sub-models indicating subspheres and combining machine learning models and high performance models will bring to something which may have a blueprint for cognitive architecture. And as always, there is a trade-off in which you start on the right side from data. You think about algorithms, you think about language, infrastructure, and unknown things, unspecified, starting with data and doing trade-offs. So it will be interesting to see how to map big, huge domain, earth science, into submodels, and then map this into cognitive architecture. As I mentioned previously, it's hyperscale, hybrid, and heterogeneous. Here is a possible layout of this platform architecture, in which I'm repeating here that on the top there is a computation, and the bottom is cognition. In computation, CPU, GPU, and in cognition is neuromorphic and quantum. Entry is, of course, coming from instrumentation and from different sources of data. Creation of climate model, then decomposition, again in this brokering piece, probably there is an opportunity for innovate or invent something, solution synthesis, and delivering insight, policies, or what comes out of this from this platform. On the right side, again, I'm hinting that most likely that scientific workflows being enriched by AI will be different, and then placing or mapping it on appropriate infrastructure will be kind of field of potential innovation or invention. Now, I have jumped with the first slide long way out to discovery, while in reality, today we have AI inquiries to understand how to combine all this together into coherent architecture, which I have advocated as a cognitive architecture, infused AI into already existing big data collections, high performance computing, and other things. On the right side, I'm again reprinting something which I have published 20 years ago on Monte Verità. There was an AI 50 celebration in Europe. Professor Nielsen late was present there, and others. And I was hinting about future system which will combine analytical reasoning skills of humans with intuitive, to come out with something which may look as a hybrid architecture, which at the end, I would suggest again, might be called as a cognitive. Now, when you look at the, so I was talking about the right side, of course. On the left side is a roadmap jumping out 50 years out, as you are all aware about situation with the quantum computing and problems of error corrections today, instability and other, and competition between big companies to come first to create a quantum computer. I would bet on quantum sensing as a first thing to become important in AI scientific discoveries. So with that, I will finish this. Again, my apologies for being seated and talking on vignettes and not design, not technology, not any kind of eventually immediately useful thing. But if you come to find something which might eventually trigger to interest to explore certain idea or eventually to protect them by publishing or patenting, then it will be time well spent.
Thank you, Marcel. Our next presentation comes from Giordano Mancini.